Hello, this is mathjazz from Almost Cool. This is the 6th video in our series of videos on derivatives. Our topic today is the derivatives of trigonometric functions. We'll start by finding and proving the derivative of sine. The derivative of sine of x is cosine of x. And by plugging sine into the definition of derivative, we get the derivative of sine of x is equal to the limit as h goes to 0 of sine of x plus h minus sine of x over h. We're going to use our angle sum identity to split sine of x plus h into sine of x times cosine of h plus sine of h times cosine of x. And that gives us the limit as h goes to 0 of sine of x cosine of h plus sine of h cosine of x minus sine of x over h. We will now break the fraction apart, and this gives us the limit as h goes to 0 of sine x cosine h minus sine x over h, and the limit as h goes to 0 of sine h cosine x over h. We will now factor out sine x from the left limit and cosine x from the right limit to obtain this expression. And we note that we know the values of the two limits that are left in this expression. The limit as h goes to 0 of cosine of h minus 1 over h is 0, and the limit as h goes to 0 of sine of h over h is 1. Substituting those in, we get sine of x times 0 plus cosine of x times 1, which gives us cosine of x. And that proves that cosine of x is the derivative of sine. The derivative of cosine is negative sine. This is done in much the same way. We're going to plug cosine into the definition of derivative. We'll use our angle sum identity to separate out cosine of x plus h into cosine of x cosine of h minus sine of x times sine of h. And then we'll split the fraction, and we will factor out cosine of x and sine of x, and we're left with two limits that we already know, the same limits that we had last time. So we get cosine of x times 0 minus sine of x times 1, which leaves us negative sine of x as the derivative of cosine of x. The remainder of our trig functions are easier to prove than the sine and cosine because all of our other trig functions we defined as being ratios between sine and cosine. And since we have the quotient rule, we can, from here on, use the quotient rule to compute the derivatives for the rest of our trig functions. So, the derivative of tangent of x is equal to the derivative of sine of x over cosine of x. And using the quotient rule, we get that this is equal to cosine of x times the derivative of sine of x minus sine of x times the derivative of cosine of x over the square of cosine of x. And the derivative of sine is cosine, the derivative of cosine is negative sine. That gives us cosine squared x plus sine squared x over the square of cosine of x. But cosine squared x plus sine squared x is 1, so this gives us 1 over cosine squared of x, which is secant squared of x. The derivative of secant is going to be, we're going to use the chain rule on cosine of x raised to the negative first power. Or alternatively, we could use the quotient rule on 1 over cosine of x. The chain rule says that the derivative of cosine of x to the negative first power, we first take the derivative of x to the negative first and plug cosine into it. That gives us negative cosine of x to the negative 2 power. And then we have to multiply by the derivative of cosine. So we get negative cosine to the negative second power times negative sine of x. And that gives us 1 over cosine of x times sine of x over cosine of x. And we get that as secant times tangent, which is what we said it would be at the top of the slide. The derivatives of cosecant and cotangent are obtained in similar method. We'll skip both of these. but it would be good practice to do on your own at some point in time. Here's a table of the derivatives of all of our trigonometric functions. There are 3 tips that I'll give you to help you memorize the table. All of our cofunctions have negative derivatives, and the other functions have positive derivatives. What I mean is, the 6 trig functions that we have are divided into sine, secant, and tangent, which are our functions, and cosine, cosecant, and cotangent, which are our cofunctions. And notice, every function that has a co as its first syllable has a negative derivative, or its derivative has a negative sign in its expression. Sine and cosine are each other's derivatives, up to sine. I mean, the derivative of cosine is negative sine, but we can remember that the derivative of sine is cosine, the derivative of cosine is sine, but since cosine is a negative function, we put the negative sign in front of it. So the derivative of cosine is negative sine. That gives us already some nice patterns for memorizing this table. The last one should make it very easy. The remaining equations all have 2 secants and a tangent, or 2 cosecants and a cotangent in their expression. So for example, the derivative of tangent is secant squared. There's a tangent on the left side of the equation and 2 secants on the right-hand side. The derivative of secant is secant tangent. There's a secant on each side of the equation and a tangent on one side of the equation. So both of those equations have 2 secants and a tangent in them. Likewise, cotangent has 2 cosecants in its derivative, and cosecant has a cosecant and a cotangent in its derivative. These 3 rules should help to memorize this table quickly, because the first 2 functions that you get are the derivatives of sine and cosine, because they're each other's derivatives, and then the other 4, you just write down whichever 2 functions are missing to get 2 secants and a tangent, or 2 cosecants and a cotangent. And then you put negative signs on all of the derivatives that are derivatives of cofunctions. Thank you for watching this video. My email address is mathjazz9@gmail.com. Our website is almostcool.weebly.com. Feel free to email me on topics of future videos, to ask questions, to tell me about errors in the videos, or anything else you'd like to email me about. I hope that you're enjoying learning about calculus. I think that derivatives are pretty cool, and I hope that you're having a great day. Goodbye.